Hi, everyone. We're going to be reviewing mean, median, mode, which are our measures of center, and range today. We introduced it to you last week. So I'm going to be using data collected from our oyster restoration project that Fifth Grade Ecology Club does. So take a look at the picture over on the side, and you'll see where I've dumped out the bag of oysters that we keep in our backyard. And I usually bring those into school. Ecology Club will measure them after they sort them, looking for dead ones. Ecology Club members will be very happy to know I only found 2 dead ones, so they are thriving right now. It says a fifth grade ecology club has been raising oysters to be placed in the Chesapeake Bay. In addition to acting as a source of food for other animals within an aquatic food web, oysters are beneficial to the ecosystem by filtering water. Upon arriving into the Chesapeake Bay, Captain John Smith observed that the bay consisted of clear water and included oysters the size of dinner plates. Due to overharvesting and pollution, that's not the case in our modern Chesapeake Bay. This project is attempting to restore the oyster population and thus help the Chesapeake Bay become a healthier aquatic ecosystem for all living things. So here is a picture of me yesterday out on the dock. Nice, beautiful day. And if you'll notice in the picture, you'll see that I have separated some groupings out. Normally we have 5 groups of students who just take a sample handful, and then they pull out 5 large oysters and 5 small oysters. And we use that to find the average sized oyster in that data set. So we're going to be working with a little bit more information. If you take a look here, this is sample 1. The measurements are all in millimeters. So I literally had a ruler that had millimeters and centimeters on it and measured them, and these are the results I had. So my first question to you is, what is the range of the data set? And remember, the range is the one that has those different names. It can also be called the degree of variation and the measure of spread. So if I'm thinking about the range is the difference between, that's what I'm remembering. It's the difference between the highest number in the data set and the lowest number. So when I scan my data here, 9's pretty low. 30 looks like it might be high. Oh, there's 35. 37. Okay, so 37 minus 9 will tell us what the range is. So on my paper, whiteboard, and just because I can, I'm going to use my calculator. I'm going to put it in twice just to make sure. 37 minus 9 equals 28. All right, so I've got 28. 28 what? 28 millimeters. So the range, or the difference between the longest oyster in that data set and the shortest one, is 28 millimeters. That's a pretty big difference. That's the spread of that data. So here's a little picture up here where I zoomed in, and you can see that we're measuring from one end to the other of the oyster. This is still sample 1, and now we want to find the measures of center for the data set. Remember to put the data in order from least to greatest first. And we're finding the average size of an oyster in that data set then. So what I always do is I rewrite all those numbers on my paper. I'm going to count them all to make sure. I wonder if it's an odd or even number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I write 10 and then I start copying them down. Well, I've already done it, so here's my list. And I know I have them all copied. Now I'm going to put it in order from least to greatest. So I'm starting out with the 9, and then I'm crossing 9 out on my original list that I did. This is super important. It may seem like, oh my gosh, why do I have to keep doing that? That's tedious. It is kind of tedious, but once you do it and you get it set up right, You're not going to make a mistake. So as I'm scanning right now, I'm looking for the next largest number, which is, I hope you're doing it too, 15. After the 15, we have 17. So I'm checking off 15. I'm checking off 17. I am looking for the next largest number in that data set. It appears that it is 24, followed by, what do you think? 20. And I'm crossing it out. That's what you're hearing. 30 seems to be the next largest one. There's another one that measured 30, so I have to write it. And I can tell I'm going to have to rewrite my data here because I did not do a very good job of doing it nice and straight. 35 is next. Another 35. And 37. I wrote that so messy. Okay, so I took a moment to go back and I rewrote my numbers and now they're in a nice line. I also counted to make sure I had 10. I do. And as you see, I was crossing things out as I was recording them down. Good strategy. So the first thing we're going to look for is the mode. I know it's not listed first, but I like finding the mode because it's the easiest one to do. Remember, the mode is the one that appears the most, just like the word mode, and the word most starts with M-O, and that's how I remember it. So we're looking for numbers that are repeated in our data set, and the one that appears the most is what we're going to write down. So as I'm looking at, 35 is twice and so is 30. There isn't any number that appears 3 times. So because they both appear 2 times, we have 2 modes for this data set. It's kind of like they're in a tie. So my mode is 30 and 35. And you just write that like this, with a comma there. The median is the one I always go for next when I'm trying to find these measures of center. Remember, I like this one. It's kind of fun. We're just going to go and tick off numbers from the side where we had the least amount and then go over to the greatest. And we just keep doing that until we arrive at something in the middle. Now, the thing is, remember, you have to have a match. So if I check off something here on this side, I have to have a match. It's like one here, one there, one here, one there. So I'm going to do that. One here, one there, 3 on this side. Now I have 3 on that side, 4 on this side, 4 on this side. Oh no, what? I can't cross them both out. Oh yeah, now I remember. If we have an even number in our data set, there's 10 here. Then I have to do a little bit of work. Remember, to find the median, we have to add and divide, just like we do for the mean, because we're finding the mean there. So I have to add 20 plus 30, and that's equal to 50. Again, remember, you can use your calculator. 50 divided by 2, oh, that's an easy one. Again, you can use your calculator, is 25. So the median is 25. 25 what? Millimeters. Okay, last one is the mean. The mean is tough. You have to add them all up and divide by the total number in your data set. So we had 10 measurements here, which means that we're going to divide by 10 after we add them all up. Grabbing my calculator, a lot of numbers here. I'm going to do this more than once just to make sure. So 9 plus 15 plus 17 plus 24 plus 20 plus 30. Ecology Club members, this should sound familiar because we do this every month. 35, 35 plus 37. I have 252 right now. I'm going to do it again just to make sure I don't make a careless error with my adding. 9 plus 15 plus 17 plus 24 plus 20 plus 30 plus 30 plus 35 plus 35 plus 37. 252 again. Yay! So now 252 divided by 10. I got 47. I'm going to do that again just to make sure. 252 divided by 10. Yeah, I got something else. I knew there was something wrong. That's why you do it twice. I'll do it one more time. I know it's right this time, though. 252 divided by 10 equals 25 and 2/10. So the mean is 25 and 2/10 millimeter. That means in that average sample, the pile that I had for them of 10, the average size oyster is 25 and 2/10 millimeter.